Hopefully, come away. I
50.
Oh, 2.
Oh, master. I say be 85 now. I'm saying that we move on more.
That's what it is. Very nice. Okotoyaka, Franco.
Yeah, hello. I think it's left with some 2 people, so let's wait for some 2 minutes. Okay, so we have a question. Okay, can you see the screen? Hello. Can you see the screen?
Yes, we can.
Okay, right. So yeah, my question, Audrey. Let's look at the first one. Does this production function exhibit these 2 properties? Hey, you talking? Yara? Yara?
Yes.
Can we say that this production function exhibits these 2 properties?
Yes.
Yes or no?
Yes, it does.
It does, eh? What did you get for the first order? Please, everybody, take your pen, take your book, your pad, your paper, and then differentiate y with respect to n. Here too, we'll be doing math, a lot of math. So get up your loins. Are you done?
Yes.
Okay, so show it to me. Everybody, show it to me. Show it to me. You won't show it there. Okay, let's continue. Yes, yes, it does. So I hope and I trust and I believe that you've all done it. Thank God.
Yeah.
Yes, it does. Let's look at the second one. Does it? Y equals 20n minus 0.25 n squared. Does it exhibit these two properties?
Negative.
Does it? Yes or no?
No.
No. The first order is negative. And I think the second
Yeah.
order it will be constant. Second order. It will be negative. So the second one is not. The first order is less than 0. The second order is less than 0. But the first order is supposed to be greater than 0. Okay, so the second one does not. Okay, so you understand it. We thank God. Okay, let's move on. Right. We want to look at the marginal product of labor curve. The first curve that you see here is the production function. Okay. So Y is on the vertical axis, and then the units of labor, N, is on the horizontal. Okay, so that's what we have here. There's a typical production function. In SHS, we call it the TP curve, the total product curve. Okay, so that's the curve that we have here. The marginal product of labor measures the changes in what? In output as a result of a unit change in the units of labor hired. Okay, so what we have here is talking about the changes in Y as a result of a unit change in N. That's why the changes here are what? Always one. But let's look at the first one. Let's look at the first one. When you stand at B, when you stand at B, the units of labor hired was 1, right? 1. And then we were having, I think, around 9 units of output. When we move, if there's a change from B to C, we want to measure the marginal product. The change in labor is 1. Okay, so what is the change in what? Output that is caused by this unit change in N. That is, we move from B to C, and C is around 19, right? So 19 minus 1, the change in Y, we are getting what? 10. That is why we have 10 here. When the units of labor changes from 1 to 2, then MPN is 10. MPN is what? dy dn, which is changing Y over changing N. Is that okay? So that is how we get our MPN curve. So we'll get to the point 0. MPN becomes 0 when the production function what attains its maximum. When it attains its maximum. So as soon as the production function begins to fall, when it enters into the negative returns, then the marginal product of labor tends to be what? Negative. Okay, it tends to be negative. Okay, so this is what I was talking about, just trying to explain the diagram here. Okay. So what you have to know is that basically we get the marginal product of labor curve from the production function. And how do we do this? We do this by just getting the additions to output whenever there's a unit change in the units of labor hired. Okay, the units of labor hired. So if labor should change from 4 to 5, and then the change in Y is 5, then it means that our MPN there is calculated as what? 5. That is change in Y we're changing, and which is 5 divided by 1, just like the total marginal product derivation that we know. Okay, so when we have the units of labor on the horizontal axis, and then MPN on the vertical, then this is our MPN curve. Okay, but normally we don't consider the constant return section, so we take the diminishing section, okay, from here to here. That is the MPN curve, okay, which is derived from the production function. Okay. Okay, so now we want to go into the labor market. When you go to the labor market, as we know, for any market, we have the demand side and then we have the supply side. So for the demand, those who demand for labor services are firms. Firms demand for labor what? Services. And then households, they supply labor services. Okay. So let's take note of this. Demand for labor comes from firms, and then the supply of labor comes from what? Households or individuals. Okay. Right. So the labor market consists of the demand for labor side and then the supply of labor side. So let's look at some simple assumptions. And the first one is that firms are profit maximizers. They always try to maximize profit. And as households, we try to maximize our utility. We try to maximize our utility. And here too, the firms take price level and the wage, that's the nominal or the money wage, as given. But for households, they take money wage as constant. When we get there, we'll understand what the assumptions are all about. Okay, so these are some of the basic assumptions that we have to. And just know that, just like any market, there should always be an equilibrium. Okay, whenever demand equals what supply, we need to get a stable condition in the market. So when this condition is met, when demand is the same as supply, that is where we can get our equilibrium N. And after getting an equilibrium N, we can get our equilibrium Y. Okay, right. So now we want to look at the demand for labor. We want to look at demand for labor. Okay, so firms, what they want to do is they want to maximize profit. Whatever a firm does is because that person wants to maximize profit. So their job is to get the ideal units of labor that can help them maximize what? Their profit. And this is the condition, that the price of the commodity times the marginal product of labor should be the same as the money or the nominal wage. When you P times MPN is called marginal revenue product of labor. MPN is marginal product of labor. When we add P, then we are getting marginal revenue product of labor. And this condition, let me try to explain the condition. The wage is the cost that the firm incurs whenever he hires one additional unit of labor, wage. Okay, and then the P times MPN is the benefit, the returns that he gets from hiring that labor. So just like what we're looking at on Tuesday, whenever your benefit is the same as your cost, then you tend to be in what? In a stable condition. Okay. So this condition must be met, that the marginal revenue product of labor should be the same as the money wage or the nominal wage. This, let's take this as what the equation one. So here P is the price level. MPN is our marginal product of labor, which is derived as the DYDN, differentiating the production function with respect to labor. And then W is the money or the nominal wage. Okay, money or the nominal wage. So when we look at equation one, we can get another equation from this by dividing through by P. When you divide this equation one through by P, then we'll be getting what? MPN is equal to W over P. Okay, so in essence, these two equations are basically the same. Okay, they are basically the same, but it depends on how you want to give the explanation. We call this the real wage. W over P is the real wage, which means that the firm can maximize profit when the marginal product of labor is equal to the real wage. Okay, most of the times we are not interested in the nominal variables. If you take something like wage, no one is interested in nominal wage. We are interested in real wage, the quantum of goods and services that your nominal wage can buy. So it's like the households are interested in the real wage, and then the firm too is interested in the addition to output that this real wage that he is going to pay is going to fetch him. Okay, so this part is the marginal product of labor. That is the benefit that the extra unit of labor is going to add to the total output. And then this is what it costs the firm to hire that unit of labor in real terms. In real terms. Okay, so basically the two equations are what? Are the same, but it just depends on how you want to give your explanation or interpretation. Okay, right. So we will need a demand for labor curve. Okay, we will need a demand for labor curve because graphically, if we want to attain the equilibrium, then the two curves are supposed to intersect. So how do we get our demand for labor curve? Okay, now from equation one, okay, from equation one, we said that P times MPN is supposed to be what? The same as the money wage. And we said that P times MPN is called the marginal revenue product of what? Labor. Of labor. And they should be the same as the fixed money wage. And then for equation two, the firm will try to maximize the profit in hiring the labor in what? Equation two. That is the addition to total output is supposed to be the same as what? The cost, the real cost of hiring that labor before the firm can maximize his what? Profit. Okay, before the firm can maximize the profit. Okay. Right. So because of the existence of diminishing marginal returns, we just consider the falling part of the MPN curve. Okay, there's a constant part, but because of the existence of the law, we tend to take the diminishing part, the decreasing part. So that is just the part that we'll be considering. We are just not interested in the constant part or the negative part. So let's look at these diagrams. For this one, the vertical axis is measuring real wage, and then the marginal product of what? Labor. And then the horizontal is still measuring the units of what? The labor hired. So for this one, we are trying to express MPN in terms of what? Real wage. We are not talking about the nominal. So this one is from the second equation. This one is from the second equation that MPN is supposed to be the same as what? As the real wage. Okay, that's what we have here. Okay, your MPN is supposed to be the same as what? The same as your real wage. Right, so now let's look at something here. Just assuming there's an increase in real wage from 8 to 10. There's an increase in real wage from 8 to 10. Then what is going to happen to the units of labor hired? Now, let's look at the intuition before we go to the curve. If there's an increase in real wage, it means that the cost of hiring labor has increased. Is that okay? If there's an increase in real wage, okay, because we see the real wage as what the real cost of what? Labor, the money that the firm has to pay the household whenever it requires their labor what services. Okay, so if there's an increase in real wage from 8 to 10, then this is going to cause what? A reduction in demand. It's just like the normal demand and supply analysis. Whenever there's an increase in the price of the commodity, there's a reduction in demand. Demand falls. So if real wage should increase from 8 to 10, then here from 8 to 10, what is happening to labor? We are moving from point D to what? To point C. So this is where we come to. So there's a reduction in what? The units of labor that is going to be hired. Okay, so this is how we give the interpretation whenever we want to connect real wage to the marginal product of what? Of labor. What if there's an increase in price? What if there's an increase in price? If there's an increase in price, okay, it means that there's going to be what? A reduction in real wage. Okay, so you can talk about this in two senses. One, if there's an increase in price, there's a reduction in real wage because in the real wage function, P is a denominator. So real wage falls. If real wage is falling, it means that the cost of hiring labor too is what? Is falling. And as a result, the firms can hire more. You understand? Or whenever there's an increase in price, then it means that the benefit that the firms are getting from selling their commodity has increased. And we know from the demand and supply that whenever there's an increase in price, then sellers tend to what? They tend to sell more. And before you can produce more, you need to what? Hire more labor. So whenever there's an increase in price, okay, if we are talking about real wage, then what is going to happen is there's going to be a reduction in real wage. Then your units of labor hired is going to what? Is going to increase. I hope that's okay. Say something, say something. You've been quiet for too long. I'm even afraid. Okay, right. Now let's look at this one too. For this one, we are using the first equation. So the marginal revenue product of labor is equal to the money wage. Okay, but whether we use the first equation or the second equation, we are supposed to get the same what? Curve. Let's look at some of the dynamics. Now, assuming there's an increase in the nominal wage, okay, if there's an increase in money wage, what is going to happen? What this means is that now there's an increase in the cost of hiring labor. Okay, the price of hiring labor has gone up. In other words, we can just push this curve up. This curve is seen as what? As the money wage line, this line. Okay, so if there's an increase, then we are supposed to shift it upwards. And what is going to happen is now this new line is going to meet the marginal revenue product of labor curve at point C, and as a result, there's going to be what? A reduction in the units of labor hired. Okay, what is going to happen if there's an increase in either P or MPN? This curve is going to shift. Okay, the curve will shift. If there's an increase, this thing is going to shift to the right, which means that at the same money wage, now we can what? We can hire more labor. Now, just assuming, can I even draw? Let me see, I think, see. Now, assuming there's an increase in price or MPN, this curve is going to what? Shift to the right like this. So initially, this is what we're hiring. Now, this is our money wage. It's still constant. So now we'll no more hire this, but this is the unit that we'll hire. So if we are using the marginal revenue product of labor and the nominal wage, whenever there's an increase in price, there's going to be a shift in the MPN curve, and then at the same money wage, the firms will tend to demand more units of what? Labor. Okay. So I think from here you can see that there's a negative relationship between demand for money and the real wage or the nominal wage. If you take the real wage, whenever there's an increase in real wage, we've realized that there's a decrease in what? There's a decrease in the demand for labor. And whenever there's a decrease in the real wage, then there's an increase in what? The demand for labor. So there's a negative relationship between demand for labor and then the real wage. Okay. So this is what I was talking about. There's a negative relationship between demand for labor and the real wage. So now let's look at how we can do this. Hey, I didn't quote that.
Clear.
However,
Yeah, when you annotate knows the name. Annotate. Clear was it? Me who am not Jimmy.
Right. So sorry. We want to derive the labor demand function. Okay. Now we know that demand for labor negatively depends on the real wage. Okay, so whenever there's an increase in real wage, there's a reduction in demand for labor. Whenever there's a reduction in real wage, then there's an increase in the demand for labor. So mathematically, if you want to get your demand for labor, you just equate your marginal product of labor to your real wage. Then you make N the subject. Remember, MPN. MPN is what? The dy, the N, right? So when you find this differentiation, it will be in terms of N. Then you equate it to W over P. Then you make N the subject. After doing that, the N that you get is your labor demand function. Okay, it's your labor demand function. We'll use one example and then okay. Can you hear me?
Share screen though. I'm going to share more.
Okay, can you see the screen? So now what we have seen, what we've seen now is the demand for labor function is negatively related to what? to the real wage. Okay, so they are asking which of these labor demand functions are truly labor demand functions. What they are asking for is there's supposed to be a negative relationship between W over P and ND. So when you look at this, yes, it is true. Because here W over P is a denominator, right? Which means that whenever W over P increases, ND is supposed to fall. If you look at this one too, the sign here is what? Is negative. That one too is true. But if you look at this is positive, which means that whenever there's an increase in real wage, there's supposed to be an increase in labor demand, which is not true. Okay, which is not true. So I want us to look at this question. Were to use this production function to find the labor demand function. I'm coming in. I think I did. I'm running out of time. Next step. Box.
20 and minus. What if I get you get 20 minus 2 times 25 and 12?
That puts in place equivalent weight.
Yeah. We put it to the big of P. Give me some. Press SPP.
Thin.
Share we.
Zoom
there.
Okay, so let's look at the exact. I hope you can see the screen.
Yeah.
Okay, good. So this the example y equals 20n minus 0.25 n squared. We have to find what? First, we need a demand function, and then we have to look at the gradient of the demand function. So this is the solution. At first, what you have to do is we need to find MPN. Then we equate it to what? To W over P, which is the real wage. So from the production function, 20n minus 0.25 n squared, dy dn is what? MPN, which is 20 minus 1 over 2n. Okay, 20. Okay, so now the labor demand curve becomes what? We equate the MPN to W over P. Then we make N the subject from this equation. So your ND will be this is linear equation.
Hello.
Right? Yeah. Can you hear me?
Yes, but then there is nothing on your screen. It's just examples and then equilibrium wage. That's the only thing I can see on the screen.
Sorry. Oh. Can you see something now?
No.
All right. I'm coming. Come on.
Did you have it?
Oh, I didn't come see me as a time we have to. I was sharing at all.
Share a screen. But share screen has and some of them.
Let another cut. I got it. I got 5 minutes. Can you see the screen? Hello?
Yeah.
Okay.
Hello. I'm seeing now.
Okay. do you still see the solution? Can you see the solution?
Yes.
Okay, good. So this is what I was talking about. That from the production function first, you find dydn, okay, which is your MPN. This is 20 minus 1 over 2n. We had a 1 over 2 by 2 times what? 0.25. So you get 1 over 2. Then for you to get a labor demand curve, we equate the MPN to the real wage. Then we make n the subject. So by doing that, we get ND is equal to what? 40 minus 2 times the real wage. So this is a labor demand curve. ND is labor demand. Okay, the labor demand curve is equal to 40 minus 2 times W over P. So I'm sure you can see that it is negatively related. And then the labor demand function is a function of real wage. Okay, it's a function of real wage. I will send you this one too, so you can go through. Yeah? And then if you want to find a gradient, just differentiate the labor demand with respect to the real wage. So this, from this one, you find dNd dW over P. So your answer is what? -2. That's what we have here. -2. So how do you give the explanation? So this means if the real wage should increase by 1 unit, then labor demand will decrease by what? By 2 units. Are you with me?
Yes.
So just find what? Differentiate the demand function and the labor demand function with respect to real wage. Then your answer that you get, it will always be negative. So a unit change in real wage will cause this unit decrease in what? In the labor demand function. Okay. So any question today, this is what we'll do. So we've been able to derive the labor demand function from the production function by finding MPN and equating it to W over P. Unmute yourself. Obia unmuting ne ho. Me ma mu homework mwanye me boa. Me ma mu homework mwanye. Sana mmode ba. Me nsanka. So that will be the end of today's lesson. The next time, I will give you an assignment and you don't do. I won't give you any assignment again. Okay, so we'll just be teaching and listening. Okay, we'll teach and then we'll listen. So how am I supposed to know how you are progressing? I'm sure those of you who submitted yours, you've gotten the feedback. Yaya? Yima?
Yeah, hello.
I mean, have you gotten the feedback? Have you seen your marks?
Why are we supposed to go for the feedback? How are we supposed to go for the feedback?
I mean, have you checked your mail today, even yesterday night? Did you check your mail? Okay, don't worry. I will send it to you. I will send it to you, your mail again. So those who did it, Onyankopon Sham, why? Yeah, young so no Onyankopon Sham. Okay. Right, so God willing, Saturday, the same time. Can we meet a bit earlier if it's not